Okay, so good morning, all. So today we will just start with the things where we left in the last class. I think we have taken the class almost 15 days back. So I hope you have taken one or two classes on module 5. Okay, so I will just continue with the things where we left in the last class. I think in the last class we were just discussing regarding the classification of the CNC machines. Okay, so I think we discussed a few classifications, right? In today's class, I will just continue with the same classification of CNC machines, the further classifications, and we'll also just moving on to the part programming in CNC. Okay, so I think in the last class we were just discussed with the classification of CNC machines based upon the control loops. One is a open loop, another one is a closed loop control system or closed loop systems. So we discussed what is open loop system and closed loop systems also, and also with the block diagram we had just compared how closed loop control system differs from open loop control system. Okay. So in today's class, let us just move ahead with the next classification of CNC machine, which is based on the number of axes. That is, CNC machines based upon the number of axes. It has been classified into 2, 3, 4, and 5 axis CNC machines. Okay, so let us look at that. What is this different CNC axis machines, and what are the importance of having higher axis machining? Okay, so let us take the first type of CNC machine under this classification, which is a 2 and 3 axis CNC machine. See, CNC lathe, what we are using, it will comes under two axis machines where you can have the movement of the tool in X and Y direction. Okay, and there will be a two axis along which the motion takes place. The saddle will move along longitudinally on the bed, and the cross slide moves transversely on the saddle along X axis. So whereas in 3 axis machines, there will be a one more axis perpendicular to the 2 axes, but by simultaneously the control of all the 3 axes complex surfaces can be machined. So this is regarding means, in the sense 2 axis means it can move only in the 2 directions, whereas in 3 axis CNC machines which can have the motions in all under 3 mutually perpendicular directions. And moving on to the next type of CNC machine, which you have higher axes, which will have 4 and 5 axis CNC machines. See, in this case of classification, see, the CNC machines will provide a multi-axis machining capabilities. Multi-axis in the sense, apart from the standard 3-axis CNC machine tool path movements, so you can have the movements in the rotational also. So that is just like a 5-axis milling machine. So where we can have 3 X, Y, Z axes, and the remaining one will be spindle, which will be rotating along the direction A, and the other will be rotating in the B axis. So this is how we generally we have a higher axis machines, in the sense, apart from 3 rectilinear motions, you can also have 2 rotary motions also. So for example, in 5-axis milling center, so which includes 3 XYZ axis, which will have a rectilinear motion, and the 2 rotary motions. The A axis, which is rotary tilting of the spindle, and the B axis, which can be rotary indexing table. Table itself can be rotated, whereas that is what we call it as a B axis, and A axis is the rotary tilting of the spindle. So these two will corresponds to the 2 different rotary motions which can be obtained from the 5-axis milling machines. Okay, yeah, so this is the classification under the higher axis machines. So this is what the picture what you can see over here is the 5-axis CNC machine. Okay, so apart from the 3 rectilinear motions, so you can have 2 rotary motions. One spindle can be rotated, and second one is the indexing table. So those 2 they can be rotated. So this is what we generally call it as the 5-axis CNC machine, right? Now, let us move on to what is the importance of having the higher accesses. In the sense, the machines which can have more than three. See, when we have machines which are using for higher accesses, so it will have certain advantages. So, most important thing is you can reduce the cycle time. So, whenever you want to machine a complex components, okay, within a single setup, you can machine and which reduces the cycle time. In addition to the time saving, so we can obtain a improved accuracy, okay, and we can also be obtained by just positioning errors between the setups are eliminated. Most important thing is the errors which occurs during the positioning in the sense positioning of the tool or positioning of the specimen in the uh, machine itself. So this positioning will always leads to what we call it as errors in the dimensions. So this type of errors can be eliminated by using the higher access machine. Okay, and also apart from these are the two main advantages or importance of higher access machines. Apart from that, so we will have some more importance we can obtain from the higher access machines. One is the surface finish is improved, whereas the tool life is also been improved. Okay, and tool life by tilting the tool to maintain the optimum tool to part contact all the times. So this is the one important thing what we can obtain from higher access machining. So one is you can improve the surface finish, and you can improve the tool life by tilting the tool to maintain an optimum tool contact. So at all that time. Next important importance here is an improved access to undercuts and deep pockets. By tilting the tool can be made normal to the work surface, and the errors may be reduced as the major component of cutting force will be along the tool axis. And the next one way what we can say here is higher axis machining has been widely used for machining sculpture surfaces in aerospace and automobile industries. So this is what the way we can say the importances of a higher axis machining, right? So if you find any clarification, any doubts, you can stop me. Okay, so we will have a discussion and later I will just move. Okay. The next comes is the turning center. The traditional center lathes have a horizontal beds. The saddle moves longitudinally and the cross lathe moves transversely. Although the tools can be clearly seen, the operator must lean over the tool post to position them accurately. Concentration of chips may be creating a heat source, and there may be a temperature gradients in the machine tool. Keeping the above points in view, the development of a structure of a turning center leads to the positioning of a saddle and a crosslight behind the spindle on a slant bed as shown in the figure 2.2. Chips fall freely because of a slant bed configuration, which is more ergonomically acceptable from the operator's point of view. See, most the traditional lathe centers, lathes will what will have center lathes will have a horizontal beds. Okay, so in this traditional lathes, we will have the saddle movement which will take place longitudinally, whereas the cross lights which will move transversely, right? So even though you can see the tools clearly, only thing is the operator must lean over the tool post to position them accurately. So I think this you might have been experienced when you have worked on a lathe. So when you worked on a lathe on a machine shop, so if when you have performed the different operations on a lathe machine, so when you want to position both the tool as well as the machine specimen, so you have to lean across the tool post and you have to adjust them for the correct positioning. One thing. Second thing here is the concentration of chips may be creating a heat source, and there may be a temperature gradients in the machine tool. So this is another one important things. When you look at the uh, chips which are coming out once you start machining, so the chips which are concentrating, so it will also will going to create the heat source, and which may causes temperature gradients. So all these are all what we can call it as the uh, traditional center lathes are not designed for ergonomical. It is not designed. So therefore, keeping all those points, so they have designed a structure of a turning center, so where leading to the positioning of a saddle and the cross slide behind the spindle on a slant bed. The bed is slant, okay, and once the chips falls, so they will can move freely over the slant bed configuration, and which is more ergonomically acceptable from the operator's point of view. So this is, you can see the slant bed turning center over here. So where, see, in traditional, generally the lathe bed is horizontal. So they have made here it as a slant bed. So once you start machining, so the chips which will form, they will start moving along the slant bed, and they don't stay across the tool post or whatever it might be. So it will start moving across the along the slant bed, and which will is the most important thing for the operator's point of view. Now, based on the power supply, the next what I am talking about, the next classification is based on the power supply. The CNC machines has been classified into electric, hydraulic, and pneumatic systems. Okay, so the mechanical power unit refers to the device which transforms some form of energy to mechanical power, which may be used for driving slides, saddles, or gantries, forming a part of a machine tool. The input power may be electrical, hydraulic, or a pneumatic. In the sense, see, generally, why do we need a power? See, mechanical power. See, the mechanical power is one which is makes the movement of the different parts, so which are having motions, okay, which are tended for some parts are stationary, some parts are rotary, means some parts can have a motion. So the motion is being obtained. So how the energy in to get a motion, we need an energy. So energy can be obtained from the different forms. So the different forms, in the sense, there should be some amount of energy that needs to be input to the machines, so that the machines can convert that energy into a mechanical energy, and that mechanical energy is provided, which results in the movement of the different parts. So such kind of input power, so the energy what you will going to be input to the system or input to the machine may be in the form of an electrical, or it might be in the form of a hydraulic, or it might be a pneumatic, right? So this is what the classification what they have shown, the mechanical power units. So electric motors, hydraulic system, pneumatic system, and hydraulic system. Okay, so under that we have so many things there. So that is you can have the motor having a, under electric motors we can have a motors having a controlled clutches, so DC split field and DC separately excited held. The hydraulic system, rams and motors. Pneumatic systems, again you will have a rams and motors. And hybrid systems, we have hydraulic rams backed by a pneumatic pressure. So this is just the different elements of the different mechanical power units. Let us discuss one by one now. See, electrical systems. See, these electrical systems means basically it is a motors. See, these motors are meant for controlling both the positioning and contouring machines. So in the sense, whenever you want to position a machine or whenever we want to contour, so the controlling of the positioning and contouring machines is done by means of an electric motors. So these electric motors may be either AC type or it might be DC type. Okay, and the torque and the direction of rotation need to be controlled. That is one of the most important thing. So whenever we say a motor, the the amount of torque it develops and amount of the direction of the rotation. So these are the two primary important variables that needs to be controlled. See how we can control the speed. Speed of a DC motor can be controlled by varying either electric field, means field, or the armature supply. The clutch control motor can either be a DC or AC motors. In the sense, the speed, especially the speed of a DC motor, we can control it by varying the field or by just supplying the armature. And of course, you can have a by using a clutch also you can control the motor speed. So either it might be an AC or a DC motor, and they are generally used for small machine tools because of the heat losses in the clutches. In the sense, the clutch control motors are specifically meant for small machines because this kind of clutch or control motors will involve in the heat loss. So therefore, so generally they use it for a small machines. Okay, and split field motors are the simplest form of the motors and can be controlled in a manner according to the machine tool. In the sense, uh, in place of the split field motors, means motors field has been split, and they are the very simplest form, they say, and can be controlled in the similar manner according to that of machine tools. And of course these are also very small, and they run at very high maximum speed, and also require reduction gears of higher ratios. Separately excited motors are used with the control systems for driving the slides of large machine tools. And next comes hydraulic systems. In this case, uh, we use the rams or motors. So how we used electric motors in the case of electric systems. So here, this type of systems we use in the form of a rams or a motors. And these systems are also used for positioning and contouring the machine tools of all the sizes, any size. It's not that only from starting from the smallest machine tool to the largest machine tool, we can use the hydraulic systems. And the hydraulic motors are smaller than the electric motors of equivalent power. These are there are several types of hydraulic motors. The advantage of using a hydraulic motor is that they can be very small and have a considerable torque. This means that they may be incorporated in servo systems which require having a rapid response. So generally they use hydraulic motors, and the size of the hydraulic motors are smaller than compared to the electric motors for an equivalent power. Okay, so the main advantage is again the smallest size and as well as the torque that you're going to use. And this kind of hydraulic motors are very much incorporated in the servo systems, which require having a rapid response. Yeah. Next comes the different components related to CNC machines. Any CNC machine tool essentially consists of the following parts. What are those parts? We'll just list it out, and later we will just discuss the each part in brief. Okay. The most important parts of a CNC machines are the part program. Second one is a program input device. Third one is a machine control unit. Fourth one is a drive system. fifth one is a machine tool, and the sixth one is a feedback system. So these are the most important parts or an elements of a CNC machine tools. Okay, so let us discuss this first. Each elements or components in brief, of course. These things you might have studied in your sim as well as in automation. The same thing we are repeating over here. So the first important component of any CNC machine tools is a part program. A part program is a series of coded instructions required to produce a part. It controls the movement of the machine tool and on-off control of auxiliary functions such as spindle rotation and the coolant. The coded instructions are composed of letters, numbers, and symbols. In the sense, so basically a program is a set of instructions for us. So these instructions are being presented in the form of a different codes. Okay, and these instructions are very much required for us to produce a part. In the sense, so as we give the instructions to the machine tools or CNC machine tools, so based upon that instructions, the machine tool will go into operate and it will go into produce the part. So therefore, so most important component of any CNC machine is a part program. The instructions have been loaded in the form of a series of codes, and these codes will go into operate or to go into guide the machine tool so that the what component is required can be manufactured. Okay, basically this program or set of instructions will always control the movement of the machine tool and on off control of auxiliary functions such as a spindle rotation and the coolant. I think you might have written a number of part programs in your CNC lab or say sim lab, I feel, right? I think you might have done these things, same things in your sim subject also. Okay, same thing. So you might have got G codes, M codes like that. So where each code will have their respective instructions and wherever and whenever it is required, so that instead of manual operation, so that code will be given and the machine tool will go into work based upon the code what we will go into input to the system, right? So this is what the part program. So it is, of course, the part program is controls the movement of the machine tool, and of course the on and off of the certain auxiliary functions, which might be as spindle rotations or a coolant on and off, whatever it might be. Okay, and these codes will consist of letters, numbers, as well as the symbols. Right. This is the most one of the most important part component of a CNC machine tool. And the second important thing is the program input device. See, generally, the program input device means how you will go into input the part program to the CNC control. Okay, so it means these are the program input device is the means for part program to be entered into the CNC control. Three commonly used program input devices are punch tape reader, magnetic tape reader, and computer via RS-232C communication. So this is how we will going to input the set of instructions or a codes to the system. This is what we call it as a program input device. Okay. Third important thing is the machine control unit, MCU. In short, we call that as an MCU, which will be the heart of a CNC system. And the main function of MCU, that is machine control unit, is to read the coded instructions, to decode the coded instructions, to implement interpolations, linear, circular, and helical, to generate axis motion commands, to feed the axis motion commands to the amplifier circuits for driving the axis mechanisms, to receive the feedback signals of position and speed for each drive axis, to implement auxiliary control functions such as coolant or spindle on off and tool change. So these are things what you already been known and already been studied in your lower semesters. So what is the basic functions of a machine control unit? So machine control unit is the one which will going to read the instructions, coded instructions, and that code will be decoded. Means it is written in the one language, and that will be decoded into the other language where the machine tool can understand, to decode the coded instructions and also to implement the interpolations. The most important thing is so based upon the complexity of the part or the geometry of the part. So you might be having different interpolations, which might be in the form of a linear interpolation or circular or helical. The main objective of interpolation is to generate the axis motion commands and to feed the axis motion commands to the amplifier circuit for driving the axis mechanisms. And also this MCU, the machine control unit, it receives the feedback signals of position and speed for each drive axis. And also it implements certain auxiliary control functions such as coolant or spindle on off and tool change, whatever it might be. So these are the main functions of MCU, because the MCU will forms an heart of a CNC system. So the most of the functions of the machine tool will be having a control under this machine tool control unit. Okay. Then the fourth component is a drive system. A drive system consists of an amplifier circuit, drive motors, and ball lead screws. So the drive system, so where we need to have the movements. Okay, so this the drive systems will consist of an amplifier circuits, drive motors, and ball lead screws. The MCU feeds the control signal to each axis of the amplifier circuits. The control signals are augmented to actuate the drive motors, which in turn rotate the ball lead screws to position the machine table. So, in the sense, the drive systems are basically are meant for positioning the machine table. So this will going to be happens from the amplifier circuits to the drive motors to the ball screws. So what happens once the set of instructions has been fed to the machine control unit? So these machine control unit feeds the control signals. Control signal in the sense which might be in the form of a positional signals as well as the speed signals of each axis. In the sense, if you have a multiple axis machine system, if there is a 4-axis or 5-axis, whatever it might be, that would be any axis of machine tool you are using. So that position and the speed of the each axis will be first fed by the MCU to the amplifier circuits, and these signals are then augmented. So they are called, those signals are called control signals. Control signals to control the position and to control the speed of each axis, and these control signals are augmented to actuate the drive motors. Means drive motors will be there, so those drive motors will be connected with the ball lead screws. So to augment these drive motors or to actuate these drive motors, the control signals are augmented. Okay, so control signals are augmented using the amplifier circuit, and they will actuate the drive motors. And once the drive motors actuated, they will going to rotate the ball lead screws, and the movement of the ball lead screws will start positioning the machine table. This is one of the most important component of any machine tool, because positioning of a machine table is very important in obtaining high accurate machining or high accurate products. So therefore, the tray systems will play a vital role in positioning the machine table with a amplifier circuits, a drive motor, and a ball-head screws. And the fifth important component of machine tool is the machine tool itself. CNC controls are used to control various types of machine tools. Regardless of which type of machine tool is controlled, it always has a slide table and a spindle to control of position and speed. The machine table is controlled in the X and Y axes, while the spindle runs along the Z axis. In the sense, the machine tool. So basically, there will be different types of machine tools we can talk about. It might be a lathe, or it might be a milling machine, or it might be a drilling or a grinding, whatever it might be. So we have a machine control unit. These machine control units will controls the different machine tools. So whatever type of machine tool you are using, so they will generally these machine tools will be controlled with a slide table and a spindle. So this is controlled in respect of positioning and the speed. So position and the speed are the two very important parameters in the accuracy of obtaining the parts. So therefore, so how the tools will be positioned and how the speed will be controlled. So both for slide table as well as for the spindle. So that will be taken care by the machine control unit for any type of machine tools. Okay, machine table is controlled in the X and Y axis, whereas the spindle runs along the Z axis. So this is the machine tool. And the most important is a feedback system. Basically, a feedback system is a measuring system. So whenever you have any errors or any changes or deviations you can go into obtain, so immediately that signal has to go. So that feedback or that movement of that feedback these signals is through by feedback system. So basically a feedback system is a measuring system, and it uses position and speed transducers to continuously monitor the position at which the cutting tool is located at any particular instant. The MCU uses a difference between reference signal and the feedback signals to generate the control signals for correcting position and the speed errors. In the sense, so while you are giving an instructions, you might have given the machine tool so that the reference position of the tool and at what speed the tool has to rotate. Okay, so once the machine has been started, so what happens, the if because of any errors or if any kind of mistakes you might have done, so the tool might be rotating at a different speed, and it might be positioned in a wrong position, then the machine control unit will compares the reference signal with the feedback signals. Okay, so if there is any difference, if you find out, okay, then the MCU will go into generate the control signals so that errors can be minimized or for correcting the position and the speed. Okay, so these feedback systems, they can use position and speed transducers. They use the transducers because it has to position transducers and speed transducers will be there. So they will go in to pick up the signal, and they will go into give the feedback that the tool or the spindle will be rotating at a particular speed. And if that speed will not matches with the reference speed, then the difference between the speed will be used by the MCU to generate the control signals, so that the machine spindle or the tool has to be rotated at the given speed only. This is what basically the feedback will go to work. Clear? I hope you people are following. If you have any clarification, anytime you can stop me at any position. Okay. so that we can have an interaction, right? Next comes advantages of CNC machines. So CNC machines can be used continuously 24 hours a day, 365 days a year, and only need to be switched off for occasional maintenance. So no problem if you are running it for 24 bar 7 into 365 days. Nothing will happen. It will be keep on working for 24 hours and of course for 365 days in a year. And it needs to be switched off only it requires any occasional maintenances, right? Three CNC machines are programmed with a design which can then be manufactured hundreds or even thousands of times. Each manufactured product will be exactly the same. Less skilled or trained people can operate CNCs, unlike manual lathes, milling machines, etc., which need skilled engineers. CNC machines can be updated by improving the software used to drive the machines. Training the use of CNCs is available through the use of virtual software. This is a software that allows the operator to practice using the CNC machine on a screen of a computer. The software is similar to the computer game. CNC machines can be programmed by advanced design software such as a Pro or Desktop, enabling the manufacture of products that cannot be made by manual machines even though used by skilled designers or engineers. Modern design software allows the designers to simulate the manufacture of his or her idea. There is no need to make a prototype or a model. This saves the time and it's just one of the most important advantage of a CNC machines, where when you have a new product or a new component needs to be developed, so no need to have any prototype or a model. So where you can simulate using the modern design softwares and just making that you can save the time as well as the money. Okay, and also the one person can supervise many CNC machines. Sorry, once they are programmed, they can usually be left to work by themselves. Sometimes only the cutting tools need replacing occasionally. A skilled engineer can make the same component many times. However, if each component is carefully studied, each one will vary slightly. A CNC machine will manufacture each components as an exact match. Next, coming to the disadvantages over here. CNC machines are more expensive than manually operated machines, although costs are slowly coming down now. The CNC machine operators only needs a basic training and skills enough to supervise several machines. In years ago, by engineers needed years of training to operate center lathes, milling machines, and other manually operated machines. This means many of the old skills are being lost. Less workers are required to operate CNC machines compared to manually operated machines. Investment CNC machines leads to an unemployment. This is one of the major concerns. Many countries no longer teach pupils or students how to use manually operated lathes, milling machines, etc. Pupils or students no longer develop the detailed skills required by engineers of the past. This includes mathematical and engineering skills. So again, instead of having a softwares which can induce different skills for the machine people. Okay, so yeah, so because once the software has been used for training the pupil, so what happens? Uh, the people will start losing their usage of mathematical and engineering skills. That is what the major disadvantage. Coming to the applications over here, CNC machines is used in the metal removing industry, in the metal fabrication industry, in the electrical discharge machining industry, in the woodworking industry, laser welding. Okay, so the different applications we can get it in CNC machines and other industries where CNC machines are used for lettering and engraving systems, water jet machining, and CNC is even used in the manufacturing of many electrical components. CNC example, CNC coil winders or CNC terminal location and soldering. So like that, there are so many applications you can have. I think, yeah. So this is regarding the CNC machines, NC machines, and DNC machines, and their advantages, their disadvantages, and their applications. Okay. Now let us just move to the next part of this CNC machine is CNC programming. So I will just move into an introduction to the CNC programming. In the afternoon class, I will just continue with this. So CNC programming and introduction. The part programming is a collection of all data required to produce the part. It is arranged in the form of a blocks of information, and each block contains numerical data required for processing a segment of the workpiece. So I think you can see this here. See, the part programming is of two types. One is a manual program, another one is a computer assisted part program. So whatever it might be, so the process will remain same here. Process planning, job tool setup planning, access selection, machining path planning, tool selection, part programming writing, cutting process parameters planning, and part programming proving. So this is the different ways in which you can have a part programming. Okay, two types: manual program. Another one is a computer assisted part program. I think I will stop at this point today. Okay, so I think might be having a second hour class. So I will just continue the same thing in the afternoon class. So we'll have it at 1:45. I will going to share the links with you at 1:30. Okay, so we'll just continue with the CNC programming and the manual part programming. Okay, thank you very much, my dear students. If you have any clarification, you can have, we'll have interaction before I just wind up. Yeah, any clarification from anybody? So you can just have. Okay, then if you have no doubts, then I will just leave the meeting now. Okay, so we will meet in the afternoon class. Thank you very much.